Good day, sir. I am Julrico M. Aburita, and I'm going to discuss the Laplace transform, advanced engineering mathematics. So, let's go. So, again, I'm going to discuss about Laplace transform. So, this is an introduction video. So, it's all about the Laplace transform, and I will be solving Laplace transform of a constant and a simple function in terms of its time. So, okay. Mao ni ang formula. So let's start. Number 1. So for number 1, what is the Laplace transform of the constant 1? So here, Rf to t, even though it has no term of t includes here, this is still considered an f to t in time to me. So what is Laplace transform? So simply we have f of s is now equal to 0 to infinity of f to t, which is 1 here, x to negative s d dt. So simply we evaluate the integral from 0 to infinity of e raised to negative s dt. Alright, and remember that we are integrating the term of t. So any other variable inside the integral considered any other variable other than t is considered as a constant inside the integral. So we have 0 to infinity of negative s t dt. Okay, so let u is equal to negative st. So negative st du is equal, with the respect, we get the derivative of with this respect to t, it is negative s dt, and we have here dt t. So dt is equal to du over negative s. So if you perform substitution here, so we have integral from 0 to raised negative. So and substitution, we have integral from 0 to infinity raised to e raised to negative du over negative s. So I can factor out 1 over negative s because s is considered as a constant here, as we are integrating in terms of p. So we have negative 1 over s integral from 0 to infinity e raised to, we know that integral of mega are raised to negative. So use is simply in e raised to. So evaluated from 0 to infinity. So all that happened, we need to back substitute the value of u. We have here negative u. So negative st would become erased to negative st. So that will become erased to negative infinity, from 0 to infinity. Alright, we need to evaluate the definite integral or the limit. So we have negative 1 over s, so multiplied by upper limit, which is infinity minus e raised to negative s, multiplied by 0 the lower limit, so it's to negative times s infinity. This is considered as 0. This is equal to 0 over 1 over 0. So this is e raised to negative s times 0 is raised to 0. That is equivalent to 1. So if we here multiply, this is 1. So the Laplace transform, the Laplace transform of 1 is f of x of 1 is simply equal to 1 over s of A. So that the answer of our problem, so mo na ang answer sa number 1. Then manata sa number 1, proceed tila sa number 2. So mo na yung number 1. So try ta sa number 2 na side. Let's try another 1 Laplace problem. This is number 2. So let's try another one, the Laplace transform of the certain constant. Let's say again 5, or so from the formula f is now equal to the integral from 0 to infinity of f of t is negative. So we have 0 to infinity of f of t, which is 5 erase. So negative ft dt, we can factor. So we can factor out 5 of integral sign. So 5 integral from 0 to infinity in us, and a negative st dt. And we can again integrate this. If we integrate again, we have to left u is equal to negative st, and du is equal to sdt. Then ang dt is equal to du over negative s. So du over negative s. So we have to substitute that we have erased a negative, or erase u multiplied by du over negative s, so that we have to equal to, I can factor out negative 1 over s, because we are integrating again in terms of u. So we have negative 5 over s here from 0 to infinity t of e raised to u. If we evaluate that again, so negative 5 over s integral of d u 2 is simply e raised to evaluate. So from 0 to infinity, don't forget to back substitute what is the value of u. So we have negative 5 over s by e raised to negative st. That's the original function, or the general value of u. So what will happen here, so mag-evaluate ta sa limit. So we have e raised to negative st multiplied by the infinity, infinity minus e. So negative s multiplied by 0, e raised to negative s multiplied by infinity is simply equal to 0. E raised to negative s times 0. This is e raised to 0, which happen to be equal to 1. So what will happen is we have negative 5 over here multiplied by 0 minus 1. This is e raised to 0, which is 1. So we have negative here, so we have negative 1. So that is equivalent to 5 over s. So simply that the plus transform of the constant 5 is 5 over all over s or over s. So alright, so the pattern here, we actually have table of if I'm going to get enough class transform of 10, or simply that is 10 over s. Because the Laplace transform of a value of any constant is simply the value of constant over s all. So I have shown you the hard way for the long method before we proceed sa lahit na sad na method, right? So the table Laplace transform. So sa number 4 na sad ta na example. So another example na sad ta number 4. So number 4 na ta. So here the Laplace transform of t. Again, we are going back to our formula na tundaan. So kanisi na formula. Wait, so we have 0 to infinity t multiplied by e raised to negative st. So in order for us to get these two together developed, we need to recall our integration by parts. So this should be integration by parts, that u priority into sinuously logarithmic inverse algebra. So kani siya. So makuha na nato siya. So v negative st du is equal to s dt. dt is equals to du over s dt. I hope that is clear. We are going to use a formula for integration by parts as uv minus the integral of v du. So alright, ub minus the integral of v du. So what that happened, we have the integral u, which is t multiplied by v, which is negative 1 over s. So that negative st, alright, and evaluate from 0 to infinity. Alright, because that the definite integral, so we need to evaluate also with the distributed limit of integral from 0 to infinity of v du, or v is negative 1 over s is to negative s. T, that is v, r is simply equal to v. Alright, so let's evaluate the integral, or evaluate the limit here on the left side of our equation, or in the sign of turn. So we have negative t over s raised to negative st. Evaluate from 0 to infinity minus the integral of 0 to infinity of negative 1 over s raised the negative s dt. Alright, so I am going to substitute the infinity and 0 no higher and lower limits in the term, so we have negative infinity over s sinus to negative s base multiplied by infinity. We know that the e raised to negative e multiplied by infinity, that is equivalent to 0, because this is 0, 0x, this is simply 0, because that definite integral negative 0 over s, or so negative 0 times 0, right? So we have 0, simply 0. If we multiply this by any term here is, so 0 times any number would be 0, that would be 0y. This is brought by the integration by evaluating the definitive integral, and because of this, alright, the integral from 0 to infinity of negative 1 over x here is negative s dt. So simply the term is equivalent only to 0, so our equation simplifies now to negative the integral of 0 infinity. This one is the negative 1 over here, s series negative dt. Okay, I can now factor the negative 1 over s because we are integrating the respect to t, and that the constant of so negative times negative 1 over n p over s integral from 0 to infinity. Alright, erase. So, maglat yun na sa dire. Okay. So, that u again is equal to negative st. Our du is negative st. Our dt, therefore d is our negative s. So what will happen here is that we have our 1 over s integral from 0 to infinity of e raised to u multiplied by du over negative s. Again, I can popper up negative 1 over s outside the integral sign, so that would be 1 over s multiplied by negative 1 over s from 0 to infinity raised to d. Alright, and so maura na tanan ang ako, sir. Maura na ang ako. So thank you.